wanted me to have it.
Okay, so this is our warm-up, 5th period. Go ahead and hit pause until you're done with the warm-up. And then when you're ready to hear the answer, press play. Alright, so here's the answer to number 1. You're going to distribute the first term all the way through, the second term all the way through, or individually distribute each one of these terms through this one. Either way, when you combine like terms, you should get this statement. Okay, the second one, I was dividing by a linear binomial, so I chose, once again, just like yesterday, I chose synthetic division. Do you see I'm missing the quadratic term? Yeah. And when I am, I must put the placeholder in of a 0. So you bring down the first one. You multiply, you add, you multiply, you add, you multiply, you add. So today we get a remainder. Any questions about number 2? Yes, ma'am?
So you don't have to do 2 zeros for the 2? Oh,
we're only missing the square term. So we just need 1 0.
Okay.
We've got the cube, we've got the linear. Okay, on this one, I to the 9th reduces to just I. It's the same as I to the 1st. I to the 134th is the same as I squared, and I squared is -1. So -1 times -5 made this a positive 5. So throughout this first complex number, I'm distributing 2i. Through the second complex number, I'm distributing a positive 5. When I do that distribution, I get a positive 8i squared. So the I squared makes this a -8. -8 plus 10 is 2. 6i minus 5i is I. So my answer to this simplifies to the complex number 2 plus I. Any questions about number 3? Yes, sir.
Well, it's not about number 3.
What's your question?
I'm a little cold, and my...
Cut the fan off.
Okay.
All right, let's take a look at our bookwork.
Wait for the division part.
Okay, any questions on 55, 56, or 57?
wait, you got 50.
Okay, any questions about 58, 59, or 60?
Can you go over 55 and 58?
Number 55, we were distributing a -12i through 1 plus 4i. So -12 times 1, that's a -1, excuse me, is positive 12i. And then -12i times a positive 4i is -48i squared. But the I squared is like -1, so it changes the sign to the opposite. So it's 48 plus 12i.
Sometimes I just forget to like simplify it.
Sabrina?
58.
58.
Where did the 60i go?
Okay, let's take a look at it. It was 5 plus 6i quantity squared. Okay, so the shortcut we talked about yesterday was you square the first term, you double the product of the two. So the product is 30i, so if I double it, it is 60i. And then you square the last term, which is where the 36i squared came from. So if you don't have this 60i, when you are doing the shortcut, you square the first, double the product, and square the last. So the 60i comes from the doubling the product. And this is just a shortcut for that repeated multiplication, because when we do this, we get the 30i plus the 30i. So that gives you the 60i. Okay? Any other questions through 60? All right, 61 through 63. These are all just powers of I.
Could you actually do 59?
59. So for 59, we had 7 minus 5i. and then negative 3 plus 9i. So when we distribute, 7 times negative 3 is negative 21. 7 times 9i is positive 63i. Negative 3 times negative 5i is positive 15i. And negative 5 times a positive 9 is a negative 45i squared. The I squared changes that to a positive 45. 45 minus 21 is 24. 63 plus 15 is the 78i. Okay, let's take a look at the next bunch. And this is where we may have some guest teachers show us how to do this without any work. So I'm excited. You check your work.
She's serious.
I'm ready.
Louis Serio. Wait. No, she's not.
Well, when I was checking homework in third period today, there were quite a few people that had absolutely no work for 65 through 69, and I was just surprised at first, and then excited that there's another way to do it that requires no work. So, I'm ready. Any of y'all that did it without work want to share with the rest of us? Anyone?
Somebody volunteer.
Come on, someone volunteer. JC.
JC, no, she's smart.
Anyone?
JC's actually smart.
Yeah,
You really want me to.
Yeah, if you can share if your method requires no work and gets us to the right answer.
Oh, the right answer.
Yes. Yes. That is key. I don't want a method that doesn't get us to the right answer. Actually, there were only 4 people that didn't show any work on this section.
Am I one of them?
Uh-huh.
Tell us.
I did my work on a different page.
Oh, okay.
I didn't bring the page.
Yes.
For 67,
That's what they all say.
what is the
He's like,
answer? Is it all of that?
The answer's right here.
I think
Oh, okay.
but
I love watching you talk.
Can you do that one?
why?
Sure.
Because you're hurting.
Oh, you're weird, Kyle. Don't say
Oh,
no.
no, me and Simon are great buddies. We're really just building each other up.
Can you do them?
Right, Simon?
Yeah.
Can you do all of these?
No, I can't do all of them, but I would be happy to do 1 or 2.
66.
And I think if we see 1 or 2 again, we should be fine. Okay. So here we have 19 plus 9i over 5 plus i. What is the conjugate of 5 plus
5
i?
minus I.
5 minus i. Okay, so we multiply by 5 minus I over 5 minus I, which really is like multiplying by 1. So I'm not changing the value. All I'm doing is eliminating any radical from the denominator. So when I multiply any number times its conjugate, what happens to any complex number times its
They cancel
conjugate?
out.
The outer and inner are going to cancel. So really all I have to do is the first terms and the last terms, because the outer and inner always cancel. That's what we set it up to do. So we get 25 minus a negative 1, which makes 26 in our denominator. Okay, numerator, 19 times 5, that should give us 95. 19 times negative I is negative 19i. 9i times 5 is positive 45i. And 9i times negative I squared, negative I is negative 9i squared. The I squared is like multiplying by negative 1, so it changes the sign. So 9 plus 95 is 104. 45 minus 19 is 26i over 26. Now, 26 actually does divide into 104 evenly, because in there 4 times, and 26 divides into 26 1 time. So this simplifies to 4 plus I.
Would it be wrong if I put 4 plus 1i?
Of course not.
Would you like count it wrong on a test?
It's not wrong, but you don't need it.
Okay.
Okay, was there one more you wanted to see? Somebody said a number and I don't remember.
You said 66. Yeah, but I see what I did wrong.
Okay, you're good.
Can you just do any of them? Because I got all of them.
Okay, did you multiply by the conjugate?
I did. It's just, I think,
Did you multiply the numerator and denominator by the same thing?
yes, ma'am. I think it's just when I was multiplying the bottom by the conjugate, I think I just did it wrong.
Okay. Okay, I'll just pick 69. So 6 plus 3i over 2 minus 2i. What's the conjugate of 2 minus 2i? 2 plus 2i. So we're going to multiply by 2 plus 2i over 2 plus 2i. And so in our denominator, that's going to give us 4 minus 4i squared. And that's going to make a plus 4. So the denominator will be 8. In the numerator, 6 times 2 is 12. 6 times 2i is 12i. 3i times 2 is 6i. And 3i times 2i is 6i squared. So the I squared is like multiplying by negative 1. So that gives me 6 plus 18i over 8. Everything divides by 2? Definitely. So we would get 3 plus 9i over 4. And if you guys broke this up, it would be 3/4 plus 9i over 4. And the answer key for this book actually writes everything and separates it into the A plus BI form. But like I said, this used to be the only way we'd accept answers. Now it's becoming more commonly accepted that you can take the complex number written as a single fraction. Okay, let's take a look at the next group of problems, starting with 93.
Was that just plus I for 94?
It's 3 plus I. Yes.
Oh, I put 3 minus I.
Well, it's minus a negative I, and the minus a negative makes a positive.
Okay.
Yes, sir.
Could you do 93? Because I did the same thing that you did, it looks like. But I
Okay, so did you notice that these first two are conjugates?
Yes.
So we really only have to do first and last because outer and inner will cancel. So we have 4 minus a negative I squared and 4 minus, not a negative, but 4 minus I squared. This is like negative 1. So it's 4 minus a negative 1, which is
4 plus 1 equals 5.
5. And so then we do 5 distributed through the last complex number, which is 2 minus I, and that gives us a 10 minus 5i.
I wanted it to fail.
Okay?
look, I just didn't like simplify my really long fraction before I divided it back.
It's not that hard.
All right, and 109. A is incorrect. The conjugate is not 2 plus I, but it is 2 minus I.
So you know how to work?
Okay?
I'll show you how. Here, I'll show you. You just said, you know. I've never done it. Yeah.
All right. So yesterday we basically wrapped up all the operations we could do with complex numbers. We added them, we subtracted them, we multiplied, and we divided them. We raised them to powers. So we have basically covered complex numbers. Today we're going to look at simplifying radicals. Now you've already done some of that. We did some of that last year, didn't we? We simplified square roots. Okay? We're just going to add a little bit to that this year. So let's go back over what you already know, or already should know. All right, so these are our notes for today.
I did it. Yeah, dude, it was easy. I like a challenge, so I don't want this one. Yeah, I probably should. Yeah, so you probably should.
Okay, so we're going to look at two things, and we're going to do a quick reminder of things we already know. Like if we had a common base raised to a power times that same base raised to a power, what do we do with the exponents? Add them.
Oh, this was hard.
Okay? When we have a common base raised to a power and a common base divided by that same base raised to a power, what do we do with the exponents? Subtract them. Now, if we have something raised to a power, what do we do with the exponents?
Multiply them.
Multiply them.
Wait, in the division one, do you divide the two n's to get n?
Hmm?
In the division one, do you just divide the two n's to get n?
When you have a common base, like they both are, the base is n, you subtract the exponents.
Yeah.
That's what the
You don't divide anything.
So then the-
Okay, so this is old stuff. We used this last year. We did things like this. 2x cubed times 4x to the 5th would be 8x to the 8th. We did things like this. 4a squared b over 10 80 to the 8th. Let's make that 5. And we simplified our coefficients, and we said 2/5, and then we would have a to the 6th, then b to the 3rd. Do you guys remember this stuff?
Yes.
And then we would have things like -3 x squared y squared. So -3 squared is +9, x squared squared is x to the 4th, and y to the 1st times 2 is y squared. So we spent a good bit of time last year working on this. Yes, sir.
For the second one, wouldn't the a to the 6 be on top? Because it's a negative on the...
Okay, if we subtracted them, we get 2 minus 8 is a to the -6. Then where does the negative exponent go? It moves. If it's in the numerator, it moves to the denominator. So that's why it's in the denominator. Okay?
Good question.
All right, that was a good question.
Because it cleared me up too.
So, we're going to look at some stuff with exponents, but look what kind of exponents we're going to have.
Wait, do what?
We're going to have rational exponents.
We don't like those.
So, how could I think of this? I can think of this as 16 to the 1/4 raised to the 3rd, couldn't I? Because isn't 3/4 the same as 1/4 to the 3rd?
It is.
Or could I think of this as 16 to the 3rd raised to the 1/4?
Yeah, but that still doesn't clear things up.
I'm still confused, basically.
Okay.
Wait, how does 1/4 to the 3rd
So-
get to 3/4?
Now, we're still probably not happy with that 1/4. What does that 1/4 mean? Do you know?
I don't know that.
What's your...
Couldn't it also be like
A
if
quarter.
you do 16 to the 4th and then divided by 16 to the 3rd? Like if it's
No, because that would make it negative.
Oh, I think it's
No, that would make it
quarter.
something totally
It's a
different,
quarter.
not negative. Yes, ma'am.
So 1/4 to the 3rd.
Like quarto in
Well, when you do a power to a power, don't you multiply them? And if you multiplied 1/4 times 3,
Yeah.
that's 3/4.
quarter.
Okay?
Yeah.
So no matter which way we did it. So those are equivalent. So now we still have a problem. We have no idea how to simplify this because we're not real sure what to do with a rational exponent. So if we had n raised to a rational exponent, what this numerator gives us is the power that we raise it to. Well, you know what we did? Power. And then the denominator tells us the root that we take.
What?
So 16 to the 1/4 is the same as the 4th root of 16. 16 to the 1/4 is the same as the 4th root of 16. Okay, so what your brain is asking yourself right now is, what number times itself 4 times is 16? 2. So the 4th root of 16 is 2. And 2 to the 3rd is 8.
So 16. So if you have something that is 3/4, would it always
Okay.
be just half of it, or would it have 1 to 16?
It would be.
What now?
Like so, if you have any number to the 3/4, would it always be like half of that number, or would it just that only applies to 16?
So wait, why is it 2?
Like if we did 625 to the 3/4.
It would be.
Then you would go, this is the 4th root of 625 to the 3rd. So what number times itself 4 times is 625? 5 is. And 5 to the 3rd is 125. So we see how it's not always just half. Yes, sir.
What if you don't go out with a perfect radical? Like if you just had some like a prime number and you did that, like if there's
27 is not.
You can simplify part of it.
and then you just
Why would it be 2? How'd you go from 4 root?
Okay, the regular geometry class just finished this. They had to memorize their powers of 2 up to 5. I don't see why memorizing is such a big deal because we can double things so quickly on our fingers. So any of you, I would expect to be able to do powers of 2 really up to 10
I can do that.
fairly quickly. You're just doubling. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1, yeah. Okay, so powers of 2 shouldn't be a huge stretch. Now, I wouldn't expect you to know powers of 7, 1 through 10. No. But what was your homework over the weekend?
No, I got that memorized.
Okay, so your homework was to look back over or refamiliarize yourself with perfect squares and perfect cubes. If I give you something else, it's probably going to be a really small number. So I would try 2 or 3 if it's a 4th root or a 5th root. If it's something bigger than that, and some of your homework problems are, use your calculator.
Question.
But we don't get where you got
No, I got a quick question. I got
Okay, 4th root. You're finding a number that when you multiply that number times itself 4 times, it's 16. So, 2 to the 4th is 2 times itself 4 times to give us 16. Okay? 625. What number can I multiply times itself 4 times to give me 625? And Aaron said 5. 5 times 5 is 25. Times 5 is 125. Times 5 is 625.
Is that really that funny?
Okay?
Will it always be 4?
No. Let's do a different one.
You don't have to be a jerk.
All right. Right now I'm getting I'm getting frustrated with the amount of talking that's going on. Okay. So let's kind of quell the speaking. That's not the right word. What word was I looking for?
Control the speaking.
Okay, that'll work. And ask me questions if you have questions. All right.
Question.
Negative 27 to the 2/3. We haven't started the problem.
No, one
Matt.
before.
What's your question?
I don't understand why we're doing that. If why we're seeing how many times it goes into 4, or however many times 4 goes into like 625. I don't know why we're putting that in a square root because it makes me want to do square root.
It's not a square root.
I know,
It's
it
a
just makes
4th
me want
root.
to square it down.
The only root that is a square root is the one that doesn't have a number there. That's assumed to be the square root. I mean, we could put a little 2 there.
Oh my gosh, the world makes sense.
Okay? So, this is my power. This is my root. So I'm doing, I could rewrite this. I could rewrite this as 27 to the 1/3 to the 2nd, couldn't I?
You could if you want.
Okay? So this is the cubed root of negative 27 squared. Okay, the cubed root of a negative is obviously going to be a negative, because to get a negative, we have to have a negative. A negative times a negative times a negative is a negative.
Negative 3
And
squared.
that is negative 3. And negative 3 squared is positive 9. So, negative 27 to the 2/3 power simplifies to 9.
We're
Yes.
not gonna have this with imaginary numbers.
No. Okay? Yes? It's part of what we're learning. Okay, so if I gave you this, that's just the square root of 5, isn't it? How would we write that as a rational exponent? What power is it raised to?
1/5.
What root am I taking? The second. The square root of 5 is the same as 5 to the 1/2.
Wait.
Wait, what?
Oh yes. Yeah.
So then why don't
Okay.
we-
How does it
All right. What about the cubed root?
Because it's
Okay,
square.
it's a square
Okay, I'm
root.
sorry. I'm sorry.
So we don't write the little 2 there. If there's nothing there, we just assume square root. Okay? How could I write this with a rational exponent? What do you think?
1/3.
10 to the 1/3. Okay? How could I write this with a rational exponent?
X to the 1/5.
Next to the 1/5.
How could I write this with a rational exponent?
Next to the
X to the
3/4.
4/3. X to the 4/3.
4/3.
Oh.
Root always goes in the denominator.
The outside. What year?
Mhm.
Or X to the 2/3.
Tricky.
Oh.
4x.
My power is 2, isn't it?
16x.
So what did I raise to the second power in here?
16x to the
and
2/3.
2 and x.
Oh, because it's the square root.
That was a cubed root.
And what is my root?
No, oh yeah.
3.
Wait, can you
Four-
explain?
so cube root of
Can you
four
explain where
to
the 2 came
4
from?
squared.
I sure
Is
can.
that just 4 squared?
4, the square root of 4. So then it's cubed.
Are these two the same?
Yes. Yes.
Yes, they are.
I
Because
agree with
2x quantity squared is 4x squared. So if I were trying to write this with a rational exponent, everything in here has to be squared. So I have to think of this as this. So that I can write it 2x to the 2/3.
Okay, I think, yeah.
Why don't you do half x then?
So if it.
Let's do a different one.
Do another one.
What?
Oh.
So it's
gonna be,
Let's not do, yeah, fourth is fine.
4/3.
It would be 2, 2, 4.
Okay, what am I cubing in here?
2n.
2n. So it becomes
2 and
2n
3/4.
to the 3/4.
Yes.
Okay?
We got
Yes.
So all we've been doing on this entire page of notes is switching in between forms. That's all we've been doing. So whenever we have a rational exponent, we can think of this as if this was n to the a over b, the b root of n raised to the a, that's not an a, try again, a, it's not writing,
Heck, Moby.
huh?
Oh, dang.
Simon, what happened?
Goldberg, what did you do to the movie?
Simon.
Okay, it's not Simon's fault.
Oh, it's not.
Goldberg.
Uh-oh.
Seth. I mean, Simon.
I'm used to it.
Are you pressing on it?
I'm not pressing the erase
Are you
button.
writing in white, Miss
Hey, bro. I talked to your brother, Seth, this morning.
Cool.
I told him I voted for him for a homecoming card, even though you said
Do you
I
have
was
it in
voting for him.
white?
Nope. See, it's highlighted on
I
black.
said, yeah, I heard that a lot.
Okay, kind of looks like I may be crashing and burning at this point. This should be an A right here.
Simon.
So I can open it back up and it'll behave. This should be an A.
Movie.
Maybe if I switch colors.
See, but on the video you can't see that. You can't see the little pointer thing.
I know. That's not good. Okay.
Turn over again.
So I'm raising this to the A power even though the Moby refuses to write it.
Moby.
And, or, let's see, put it over here.
Well, with Alicia now, we're in privacy. No, here. Darn.
Okay, so it's not going to work. I'm just going to give up with that page.
Wait, can you write with your mouse?
All right, so the last page wouldn't work. So we can write it like this, or we can write it like this. All these things mean the same thing, don't they? Okay, I'm going to give you 2 of these to try.
I'll show you where this one.
Hey, man.
This one is cool.
Matt. Not ready.
How come this one is
That's not true. Double negative. The power comes up from the root.
I'm at a loss of thought.
There's no cube. There's a core. It's a 4.
Okay, so you're going to simplify without a calculator. Sure.
What you got back? What you get, That's what I got.
No, cool. You're wrong, JC.
Guys, it's 3.
That's not what I did.
And then you multiply or power into the third.
Yes.
And it's 27.
Why is it 27?
Okay. So the first one, 81 to the 3/4, is the 4th root of 81. And the 4th root of 81 is 3. Because 3 to the 4th is 81. So the 4th root of 81 is 3. And 3 cubed is 27. Okay, this one is the cubed root of negative 64 squared. The cubed root of negative 64, guys, is negative 4. And negative 4 squared is 16. Okay, what would happen if I went back and made this one negative? What does a negative exponent do, guys? It causes a fraction or makes it flip. So this is equivalent to 1 over negative 64 to the 2/3. So once you flip this, then it's to the positive. So the only difference, the answer would be 1/16, wouldn't it? Yep. Okay, so let's try another one similar to that. Okay. Alright, so this one was not a fraction, so we had to turn it into a fraction. This one is a fraction, so what do you do? Thank you.
27 over 64
to the 2/3.
to the 2/3.
Yep.
My boy back there in the.
So now we are doing what root? Cubed root. And then we're going to raise that to the 2nd power. So cubed root of 27 64ths is 3/4. 3/4 squared is 9/16.
I think I get it now.
I get it when I watch you, but when I do it for homework, I'm probably not going to. But
Well, this YouTube will be posted for your use.
Do you make the 10-hour loop of
Okay. Yeah.
Oh, why did you like the answer you just did? If you simplify it, that's gonna end up being the same thing but without the exponent.
No.
Like
9/16 will not simplify.
oh, okay. I looked it up.
Okay. Alright, now last year, we simplified radicals without the variables. This year, we're doing the variables. Okay, so we already know how to simplify the radical. The largest perfect square that divides it in 32 is not 12, it is 16. And it goes in there 2 times. So we know how to do the number, 4 roots of 2. We're fine. We're fine with that part. Now we have to think of, what does radical, square root, mean in terms of powers with these exponents? Well, square root is the same as what power?
So 1/2.
1/2 power. So what would I be doing to these exponents?
Cutting them in half.
Cutting them in half. So when I simplify this now, what is half of 6?
4x.
3. What is half of 17? Uh-oh, it doesn't divide evenly. How many times does 2 go into 17 though? 8. How many are left over? 1.
What?
That makes a lot of sense.
That just took it to
Another level.
another level, but just my brain is already in the last one.
School, I hate school, I hate school.
Okay, let's do another one. Okay, what is a perfect cube that will divide into 48?
16 times 3?
16 is a perfect square.
Oh, that sounds
It's a cubed root. I need a perfect cube.
Perfect 12.
We reviewed our perfect cubes.
6 and 8.
6 and 8.
6 and 8. 8 is a perfect cube.
Oh.
Okay, so when I'm simplifying this, what is the cubed root of 8?
4. 2.
2.
Some of you did not study enough over the weekend.
Come on, Goldberg.
Okay?
I
Alright,
didn't even say anything.
6 is not a perfect cube, so it stays under. Alright, this time, instead of taking half, what am I dividing these numbers by? 3. So a to the 9th divides by 3 nicely. 3.
Oh.
b to the 8th goes in 2, but how many are left over? 2. Does it go into C? Nope. So it stays in there.
Oh.
Now, let's talk about why. Because this means the same thing as this. All this stuff to the 1/3 power. And when I have a power raised to a power, I multiply them. So do you see how it ends up being 9 divided by 3? 8 divided by 3? 2 divided by 3? That's why we're dividing by 3. Okay?
So, when you put the... I'm trying to think of the word. Why would it, like, 2, the A and the B on the... Why did you put C out there at all?
Because C was only to the 2nd power. It wasn't raised to a power higher than 3.
So you can't divide it.
So you can't take the cubed root of something that's less than the cubed power.
So why did 2 be squared, like, underneath the radical on the outside?
Why are there what?
Why would be the 2 power? Like, there's 2 of them.
Okay, 3 goes into 8 how many times? 2 times. And what's left over? 2. So 2 comes out and 2 stays under. This comes out, this stays under. Okay, 4th root. Okay, I'm going to go ahead and tell you it's 16 times 2. The 4th root of 16 is 2. Does A come out? To what power?
1.
Okay, what stays under?
1.
Okay, does B come out?
Yes.
Okay, to what power?
Second.
No, it doesn't come out. It doesn't come out.
It does.
Yeah. What's 8 divided by 4? Okay. Alright. Does any go under? No.
No.
Alright. Does C come out?
Yes, to the third.
To the 3rd?
To the 3rd
And 2 left over.
And 2 left over.
Kyle, you can silver.
Okay, let's talk about your homework. Your homework says 4 through 52. But it also says multiples of 4.
So you want us to do multiples of 6? All right, I can do that.
Okay? Now, on 16, 20, and 24, I want you to rewrite it as a product of a power. What does that mean?
No clue.
That means if you had this, you could write it as 2 to the x to the 1/3 or 2 to the 1/3
1/3 to the 2.
squared. All right, that's it.
All right, guys.